Hello, we are studying nervous system. In this series, we have completed basic structure of the brains and lobes of brain, central nervous system, peripheral nervous system. We have seen the spinal nerves, cranial nerves, and today we are going to study sympathetic nervous system. How does it works? So, suppose this is your brain. This is the lateral part. Any one you can say. This is your frontal lobe. This is your frontal lobe. I am writing FL. Frontal lobe. We are studying nervous system. In this series we have completed the maximum topics and we have studied central nervous system, peripheral nervous system. We know central nervous system, there is brain and a spinal cord. We have also studied the brains, the lobes, their function, basic structure, and the spinal cord. We have seen the segments, we have seen the cross sections of the spinal cord. And in the peripheral nervous system, we know there are two types of neurons, efferent and efferent, which carries message to the brain and which brings message from brain to the organs. And also we know there is a somatic system and there is autonomic nervous system. Autonomic nervous system which acts on two type of mechanism, that is one sympathetic nervous system and another is parasympathetic nervous system. So today in this series we are going to study the parasympathetic nervous system. Suppose this is your brain, this is the lateral segment, this is your brain. Suppose this is your frontal lobe, then this will be your occipital lobe. You know all these sections we all have already discussed. This is your parietal lobe and this is your temporal lobe. So somewhere here is our limbic system. This is your limbic system. We have already discussed limbic system. What are the components by which we can say the limbic system? This is your cortex. You know the parietal lobe, it receives the sensory signals. This receives, okay, and this is your frontal lobe. You know, this is your occipital lobe, parietal lobe, temporal lobe. Here lies the limbic system. You know, this is your limbic system. Below this lies your hypothalamus here. Okay, this is your hypothalamus, and here this is your pituitary gland. So if we take this is your hypothalamus. If we draw here the hypothalamus, two parts. This is your sympathetic nervous system, and this is your parasympathetic nervous system. Clear? Now see some any signal which is coming from the any organ. This is suppose your organ. This is your organ. Suppose this organ receives hot temperature, pressure, or you can say pain. Okay, then they sends impulses to the brain through the spinal cord, and this parietal part receives the signals because this receives the sensory signals. Cortex, this is your cortex. Now what happens? Signal goes there. Suppose a dog, you are going on a road and you suddenly saw a dog is barking. you're feeling little bit fear. Okay, what happens? You have seen dog is barking. Some of the people may ignore, but some of the people feel fears. ठीक है. Then what happens? We have seen this area is activated, occipital area. Okay, we are hearing that he is barking, so temporal lobe is also activated. Now what happens? You are watching dog is behind you. Sometimes suppose he is running behind you and you are also you are scared that he is coming after you. And what happens if he bites you? Dog bites you. Okay, you are feeling pain, message going to brain through the spinal cord to the brain here. Now this part is also activated. Okay, now this brain, this part is activated. All of this will activate this limbic system. Limbic system is the center for the good feelings, bad feelings, fear, everything. Whatever we are feeling, the limbic system is because of the limbic system. Now we know that we are dog is behind you, you are fear, you feel fear, flight. In this situation, fear, flight, fight, dog is after you, you have to run. You have sent message to the brain analyzes that message. Now they need to run. So to run, we have to use the skeletal muscles. The skeletal muscle, they need oxygen. So suddenly there is a increased requirement of oxygen for the skeletal muscles. Your heart rate should be increased so that you can run. Your cardiac output should be increased. Everything should be increased. Means your heart rate, cardiac output, everything should be increased. पहले नॉर्मल था, जब आप दौड़ेंगे सब कुछ इंक्रीज होगा. वो क्यों इंक्रीज होगा? बिकॉज ऑफ दिस पैरासिम्पैथेटिक नर्वस सिस्टम. दिस इज योर axonal end of the neuron. You have seen the structure of the neuron. Okay, we have already discussed. Suppose this is neuron and this is your dendritic part. All this structure. This is your cell body, this is axonal part. Here somewhere here lies the vesicles. They are carrying the neurotransmitters. When there is a suddenly dog bites you, these vesicles gets they send signals. Dog is biting you, he has bitten you. Then the signal goes to the brain is sending back message to the organs through these neurons. At the base of the neuron, axonal part, there are the vesicles. Inside the vesicle there is a chemical. Here the chemical is, in the case of sympathetic nervous system, norepinephrine, or you can say noradrenaline. Okay, now what happens? This chemical will release, and what they will do, they will elevate the heart rate. Okay, this will goes in the heart. They will act on heart. This is your heart, suppose. This will increase your cardiac output, heart rate, and when you will run, you will get the energy to run and moving away from the fear, flight and fight situation. To boost up that condition, the demand of the oxygen, the demand of the muscles, they need a chemical which boosted these organs to produce more oxygen. So your breathing rate is increased, your heart rate increased, cardiac output is increased, your muscle gets maximum oxygen, maximum energy through this system. Sympathetic nervous system gets activated. Now understood what happened by this. Now this system is mainly to increase this heart rate. Means in the fight, flight, fear mode, this system gets activated. Now suppose you are run to a safe place where the dog is not watching you and you are basically safe from that situation. Now you are relaxed. Now this system has to stop and the cardiac output heart rate will decreased by parasympathetic nervous system, the system which will come in action after the sympathetic nervous system when everything is okay. Now brain analyzes that everything is okay. Now another system will come in action, that is parasympathetic nervous system, which will act opposite to sympathetic nervous system. When there is an increase in the oxygen demand, when there is an increase in heart rate, cardiac output, the system has done that. But after that the system has to maintain that things to balance that system. Sympathetic system is for increasing things and the parasympathetic nervous system to maintain balance, decreasing. Now अब ये normal होगा by this parasympathetic nervous system. So now this is your cut section of the spinal cord. This is the cut section. This is your suppose this is your spinal cord. Are the cord sections of the spinal cord. This is the, suppose this is your thoracic, and see the hypothalamus is sending the message. Some signals are going to the brain from the organs. Some organs getting pain when after dog bite, or heat or pain sensation, heat sensation, that goes to the brain. Brain is sending the message through hypothalamus. Brain is sending the message, hypothalamus is sending here. So see, the dog has bitten. Now after what happens, this is the cut sections of the spinal cord. This is, suppose this is the cut section of thoracic. Now brain is activated and is sending signals. Hypothalamus sending signals to this spinal cord. This is your, this is your dorsal root and this is your ventral root. This we have already discussed. So there in between this there is present cell bodies. This is in the lateral segment, lateral section. Here there will be presence of cell bodies. The neurons are there. So what we call this is junction of the neurons. This is called polysynaptic neurons. So hypothalamus is sending the impulses to this polysynaptic neurons, and we know that this is your spinal nerve. Spinal nerve is divided into two. This is taking your sensory signals to the brain through spinal cord, and this and again brain is sending signal. This is coming through this. This we have already discussed. Now we are discussing. Now let's see what are the types through which signals are coming from brain to the organs. We know there is if some signals are coming from the brain, means left signals are coming and they can jump from the right side, and also the signals which are coming from the right side, they can jump to the left side and going to the organs. There is a crossing of the signals, jumping. That we have discussed. Now suppose see, message is coming from the brain. This is coming from the brain like this. This is going this. This is the root. Sometimes what happens in the first root, suppose this is the first root, okay, some signals are going like this and they will come here. They will come here. Axon. They will end here. And another, there is dendritic portion. Another neuron. This is the cell body. This is the axon. This will carry the message here. This will terminate here. So one neuron is coming and ending outside here, and another neuron carrying the message here to the spinal cord. So there is this junction, it will appear white because this is your myelinated neuron. Myelinated, you know, it is fat containing, so myelinated axon that appear white, so we will call it white rami. This is your first route, how the signal coming. This is jumping outside and again it will go inside in the spinal nerve. This is your first route. So now this is the cut sections of the spinal cord. Suppose this is your thoracic segments, okay, and we are knowing that there is a dark band in the area. Now that part is sending message to the brain analyzing that. What happens here, we are studying that. Suppose that brain is activated, hypothalamus is sending message here. You know, this is the cut section of the spinal cord. This is your dorsal root, this is your ventral root. You know all this, we have studied that. And you also know there is a crossing of the signals also, means some signals are coming from the brain from the right portion, but they will jump to the going out with from the left side, and some will jump out from the right side. There is a crossing of the signals, you know that. So here dorsal root, ventral root, any signal going to the brain, this is your spinal nerve, they will follow this route and they will go here to the brain, okay, and like this they will go to the brain. Any signal coming down from the brain, this will follow this route and go to the organ, you know this. This is your hypothalamus, coming signals from the brain. Now this is here in the lateral part lies the cell bodies, okay, there is a cell bodies will be here, okay. The hypothalamus is sending message here. Now they will send message like this, some will go like this, some will go like this. Some of the messages I'm drawing with this, some of the message will go outside, this will terminate here. This neuron will go like this axonal part will terminate here, and another neuron carrying that message and that ending here, okay. This will come in spinal nerve. So one neuron is ending here, another is carrying that message, so there is a junction here. You know, this neuron is myelinated, okay. Myelinated, we know myelinated means containing fats appears white. So here there is the junction of the neuron of the axonal part and the dendritic part. What we call this has a particular name, this is called white rami. Why it is appearing white? So first route we know, hypothalamus sending message, this message through the cell bodies going here, terminating here, another neuron carrying that message and taking to spinal nerve. This is your first route, okay. Now we will see second route. Some of the neurons, they will go